we are finishing up the week number 8, right? We had introduced this about a week ago, discussing how is that we can now interact with the database and start thinking about implementing actual applications. And there are two aspects of that. And one of them is you have all this data that's been stored in the database, right? We've gone through the effort of designing it and making sure that it's normalized and we don't have any redundancy and all that, right? Well, but now we need folks to actually use this data, and usually it's not through a console or through a SQL client, right? Instead, usually it's through some kind of application, right? So we need to be able to build applications that connect to the database and have access to that database, and then transfer that data into a format that can be understood by the application, right? And using whatever language or framework you're using, whether it's a mobile or some desktop application or some web application or whatever it is that is consuming this data, needs to convert it into a data model that was written for a relational model, right? For create statements and SQL and blah, blah, blah. Right? It needs to convert that into whatever object-oriented representation your application is using. And so that's one aspect. And that's where we've been focusing late last week and all this week about how do you do the connectivity between this relational database and your application, right? And we're using, we talked about two ways, right? Using the Java language, obviously. One is JDBC, which is a very low-level API, and then there's JPA, which is a high-level object relational mapping API. So that's one aspect, right? Communicating to the database from an application. The other aspect, we're going to deal with that next week, which is that we are writing applications for human beings that are interacting with this data. Right? They don't want to just see raw data, right? So they need some kind of user interface that allows them to interact. They want to be able to push buttons or click here or drag or move mouses or scroll through with your fingers or your hands or gestures and whatnot, and they're going to consume things visually. So that's the topic of next week. How do you write a UI that is driven by data? Okay, I'm going to be. I mean, there's a plethora of options for user interfaces, right? And so I'm going to choose a particular solution that is very, very popular and very very sought after in industry, and it's very lucrative if if you become proficient at it. I'm gonna give you a crash course on React.js, right? It's I'm gonna give you just enough tools that will be enough for you to build something that allows you to interact with a database, right? I'm not gonna go into a lot of detail, enough that you can build something useful, right? That can create something, can delete something, can find something, retrieve, right? And render it in a very, very simple UI, okay? And talk about the all the aspects about building applications that are data driven, right? That are database driven, and what are the things that you need to consider. In particular, all the CRUD operations, create, read, update, and delete, which are the most common things that you do with any table, any record, right? So, well, how does that translate? Today we'll see how does that translate to communicating with the database. But next week we'll see how does that translate in the user interface. Okay. Yeah. So these 2 weeks are mostly to get you going, getting you ready to start working on your projects, right? So that your project will be building some small application that is data driven, that talks to a database, right? And you're free to use other tools, other languages, other databases. You don't have to use MySQL for your project. And you can certainly use Postgre or MongoDB or Firebase or any other database. It's fine. Also for your if you're not using, you don't have to use SQL Server. I'm sorry, you don't have to use SQL at all, right? If you are using a non-relational database, right, you can absolutely use whatever that non-relational database users. And we'll talk about non-relational databases in an upcoming lecture, and what are the differences and contrast, compare and contrast. Also for the user interface, right? If you've taken a course in other courses that have introduced you to, or of other user interface solutions, you're absolutely welcome to use those instead. I needed to choose a user interface solution, so I chose React.js. I'm going to give you enough tools, enough a boilerplate code, enough examples that my hope is that you should be able to tailor what I give you to whatever solution, whatever it is that you're building for your project. Okay, and we'll go over that next week. So this week we're talking about how do we communicate with the database with an application. Next week we're gonna talk about, well, how do you render that? How do you interact with the application from a user's point of view? Okay. All right, excellent. So let's keep talking about communicating with a relational database. All right, so let's see. I'm going to jump right into the depths. Here we go. All right. Before we get started, any questions? Oh yes, I did want to talk about a bug in the assignment. Let me show you. In the assignment, the ORM assignment that you are currently working on, let me just show you. There was an issue that some students were reporting, that they were seeing some errors when they ran the sample code. And it stems from the fact that my create table has these two fields, and you might not have that field, these two fields. Also, your database might have an additional field which is not here. I think you have like a handle varchar field in there, which I don't have here. So the workaround is actually very, very simple, right? It's very, very simple. And it basically entails on removing a null here. The last week when I introduced this source code, there were two nulls right here. Okay, right. So to fix whatever error you might be having when you run this code is very simple. You just need to remove that null right there. Okay, and everything should work fine. I helped several students already. But they came to office hours and we ran this, and that solved the issue. So here as well, okay, in this line, there were two nulls. You can just remove one of the nulls, and then you should be okay. Basically, is removing that last null in the create user, and that should make it compatible to your particular implementation of the users table. Okay. All right. So please try that and let me know if that works out for you. Let's see. One of the students says, I think you should also change the Java code for setters and getters. Well, you mean for the JPA or the ORM side of it? Maybe, is that what you refer to? Yeah, Java user class. Yeah, you might need to modify this user Java class. Probably the fix might be as follows, right? Where you comment those two, and I'll make a post. I'll make a post for everyone, but you might need to comment that, and you might need to have this here that says handle, and then regenerate all the setters and getters. Okay, and that should fix that. And I should spell that correctly, handle. Okay, so basically remove that. Anyway, I'll make a post about this as well. All right, let's get back. So last week we got introduced you to the ORMs and JDBC and connecting to the database and whatnot. So today we're gonna go farther. We're going to cover the material in earnest, right? Just make sure that we don't skip over any of the necessary topics. Let's see, there's a chat on the question in the chat. When will the correct answers for the exam be released? Yeah, so there's still one person that was needed to take the exam late. I'll make it available so that once I'm done, so that folks can take a look at it and let me know if there's some feedback. All right, so let's talk about this. So ORMs are object relational mapping, right? And what they try to do is to map these two different worlds, right? On the application world, right? We represent data using classes and object instances and whatnot. Whereas in the relational world, we have tables and records, rows, foreign keys, and primary keys, and we need to convert between the two, right? And that's done usually through a solution called ORM, or object relational mapping, right? Now, there's tons of ORM frameworks out there, depending on what language you're using, what framework you're using, right? And we happen to be using Java, and in there as well, there's several solutions. But if you instead are using .NET or Python or PHP, right? Each one has a plethora of solutions, ORM solutions, right? We just happen to be using one of them, is called JPA. JPA stands for Java Persistence API. And just a little bit of history here. When Java first came out with its ORM solution, right, it was called the EJB, which is Entity Java Beans. And everybody hated it, right? It was so hard to use. It was unnecessarily complex, okay? And, I went through the whole thing and I really hated it. And so other companies started coming up with their own solutions, right? Hibernate became very, very popular in the community. It had a very, very simple way of mapping these two data models. And so, it became so popular that a lot of their ideas ended up being part of what is now the standard ORM solution for Java developers, right? So yeah, Hibernate still lives on as JPA, okay? So yeah, so we're basically using a Hibernate solution for our object relational implementation, okay? So yeah, so Java Persistence API is it's a popular ORM based on Hibernate. It's going to map classes to tables. It maps object instances into stored records in a database. It maps properties to columns and SQL data types into Java data types. All right, so getting started. So here's just some configuration stuff that I'm just going to skip over. We did go over a little bit in the assignment, and you should already have everything configured. And if you run into issues, certainly the TAs and myself are going to help you through that configuration, getting you up to speed, right? So there might be a little bit of growing pains as we set up this environment, but TAs and myself, are ready here to help you out. Let us know, and we can certainly jump in a one-on-one and try to get you going there. Okay. Yeah. So let's get started with actually using it, right? So let's talk about mapping tables to classes, right? So mapping tables to classes means that there's already a table out there. Somebody created this table, many years ago, right? And we have been tasked with integrating with this table, right? It has some legacy information. We can't touch the schema. We can't, we can insert, we can update, right? But we cannot touch the schema, right? So we have to, communicate with this table and create a Java class that maps to it. Okay, so the table is, let's say this one, the courses table, right? So let's take a look at that courses table for real in MySQL. So if we head over to MySQL and connect, we have it here in our schema. We actually have the courses table over here, and there it is, right? So let's close a couple of things here. Okay. And so we have the following information. We have here just a couple of courses, CS1234, and just other courses here. CS3200, CS5200, And we can insert a couple more here. We have CS 5610 and CS 4550 and CS 4500. Right, just a couple of others. So let's insert a couple more tables. So imagine this table already exists. We can't touch it, right? We can't touch the schema. We need to integrate with it, right? So the way we're going to integrate with it, right, is that this is what the table looks like, right? And that's the schema for it. And we would like to create a course, right, in the object that maps to this table, right? So let's do that. We have some data in the database. And so we need to consider some of the challenges of mapping these two different worlds, right? Because there are some conventions that are different in both places, right? So for instance, in a relational world, everything is case insensitive, whereas in the object world, it is case sensitive. In relational model, we use underscore to separate words, whereas in the object world, we use camel case, right? In the relational model, we use plural nouns, whereas object model, we use singular nouns, right? So all these are quite different, okay? So let's get started. Very innocently, let's start creating a class and see what we can do, right? So let's get our favorite IDE up and running. And if you remember, we had created a project for this section. Let's bring that up, see where we left off there. We'll say open. Let's see, 04. And I think it's this one. Okay, let's open that. All right, excellent. So, all right, so in here, we had created a directory where we're going to put all the models, right, of anything that we want to map, or that we want to represent data, right? We're going to put it in here. So let's create a class here for representing courses, right? So we'll need a Java class, and we'll call it course. Notice the naming convention, right? In Java, we capitalize the first letter, right? We use a noun, but it's singular, whereas in relational based databases, it's plural, right? And it's all lower cases, okay? So let's start doing the mapping. So the mapping entails on annotating our class, establishing the intention that we want to map this class to a table. Right now, by default, the mapping would assume that the name of the table is course, all lowercase and exactly the way it's spelled here, but with lowercase c. Right? Well, we can override that behavior and say that actually the name of the table that we want, right, is courses. Courses, okay, and that's how, because that's how it's spelled in the database right there, courses. Okay. We also have a couple of fields here. Now I am going to deliberately misspell one word. Well, not misspell. I'm going to use a different name for one of the fields. Okay. Notice that the fields in the relational model, right, are the columns are ID and title, right? Where ID is an integer and title is a varchar. Now I am deliberately not going to use ID here, right? And instead, I'm also going to use this title here, with which this title does map perfectly like the column here, but I'm deliberately not calling this ID. It would be too simple. Okay, so just as a to use this as a learning opportunity, right? If the fields that match perfectly, the ORM knows what to do. Right? It understands that this field title maps to this column title. Perfect. But it gets confused when it says fields here that don't match fields here, columns here in the database. So we need to tell it, how do we resolve that discrepancy? Okay. So we're going to resolve it here by annotating here that the column that this field, this course field, this course ID field is going to map to a column whose name is ID. See that? Now it knows that which fields map to what field. One of them is being done implied automatically, whereas this one we are explicitly saying what field it maps to. Make sense? All right. All right, so let's go a little further. And so we did that. The notice that I am just putting here some colors so that we let you know that this table is mapped to this create on this side, right? So the next thing, right? We name this field ID. All right. So the next thing we're going to do is that here the schema declares this ID as the primary key. So we have to, on the other side as well, tell our ORM that the primary key is this one, the course ID. And we can just add another annotation here, ID. So these two annotations are applicable to this field down below, right? And ID means that is going to be my primary key. The other thing that we know about this schema, whoever create the schema, we know that it was declared. Right? We can look at the schema here, right? We can say, we can look at courses, and we're going to send to the SQL editor the create statement. So this is the create statement that was used originally, right, to create this table, right? We see that there's an auto increment there, right? So the way we're going to annotate that on our Java side is that we're going to put here generated value, right? This value is generated by the database, and the strategy that it's being used, because this is MySQL, it's using the identity, which really converts into auto increment. Okay, everybody good? All right, so this allows me to map this class to that table. So I'm going from a class, mapping it to an existing table. Perfect. We also need to add here all the setters and getters for each one of these fields, right? Otherwise, we would not be able to read any of this data because everything is private, right? So we're going to generate, and we're going to say the setters and getters, and we're going to say all of them, and there we go. We have all the setters and getters. Perfect. We're done, right? So this class is mapped to that table. Done. Right? So how do we now interact with that table, right? How do we interact? We already know how to hold the data between the two. We need to now be able to communicate back and forth. Let's see. There was a question on line 9, 10, 11 applies to only line 12, correct? Let me see. So I think you're referring to the course. Yeah, these lines 9, 10, 11 apply only to line 12, correct? Exactly. Yep. Annotations can be stacked one on top of the other, right? And they only apply to the very next Java line of code, right? So these two apply to the class, and these three, right, apply to this one variable. Yep, good question. Where'd my chat go? Okay. All right, so let's keep going. All right, so we have that. Let's keep going. Let's take a look at. So we did that. Let's. So notice that he's a graphical, colorful representation on what parts of the table of the relational world, right, of the relational model, which pieces map to the object world, right? And notice that all pieces are taken care of, right? The entity table and the name of the class map to the create table courses, right? And so on and so forth. All right, so let's keep going. Now that we have the, how we representing the data on both sides, we need to say, okay, well, how do we communicate between the two worlds? Who is going to shuffle data back and forth, right? Who's going to convert a relational record, right, into a object instance, right? And we explored that late last week. We used JDBC as a very low level API that allowed us to read a record and then instantiate a Java object. Then earlier this week, we say, oh, well, there's a better way of doing that, right? There's an easier way using ORMs. ORMs can do this for us, right? And then it says, oh, well, writing a DAO, a data access object, right? Trivial using an ORM, right? It's very, very easy. But we need the DAO, right? So we need to create a DAO, and we saw that after we created our very first DAO, we saw if you start creating lots of DAOs, you'll notice that there's a pattern. Okay, they all behave very similarly, right? They all provide all sorts of CRUD operations for creating, reading, updating, deleting, right? So here's one that we would write for our course, right? A DAO, a course DAO that will allow you to retrieve all the courses, find a particular course by its ID, create the course, update the course, delete the course, right? And then if you want to write it for another table, like a section table or student table or faculty table, right? Or department table, enrollment table, then you would create a DAO for that table, right? Here's one that you would write for the section, right? Again, find all sections, find section by ID, create section, update section. So they all look the same. They all have more or less the same kinds of operations, right? So ideally, right, you would notice this pattern and say, you know what, I've written one too many DAOs, right? I mean, the only thing that's different between this one and that one is that one is for courses and the other one's for section, right? Course, section. Other than that, right, they're basically the same. So the idea is could we encapsulate all this behavior into a reusable module, right, that automatically does this, and we can pass it as an attribute, as a parameter, what it is that we want to CRUD, right? We want to CRUD a section, or we want to CRUD a course, or a student, or a department, or whatever it is. As long as we can parameterize it, it can do all this for us, right? And that was the intention of the repository. The repository, in particular, the CRUD repository, implements all these CRUD operations. You just need to tell it what it is that you want to CRUD, right? And here we're telling it that we want to CRUD a course, right? And oh, by the way, it also needs to know what the primary key is, the data type for the primary key. So this is what we're doing, right? We are configuring the CRUD repository to CRUD, create, read, update courses. We're going to do the same thing for the sections, for the student, for the faculty, right? We would build these different repositories. Okay, so let's do that. Let's create a CRUD repository for our course. Let's go back here in the source code, and here in the repository, let's create a new class. Actually, it's not a class, it's an interface, and it's called course repository. And in here, let's copy and paste. Let's copy and paste it, and let's go over this source code just for a bit. All right, so it's looking for course. Which course are you trying to? So let's import it. There we go. And also it needs this one too. There we go. Okay. So here's our course repository. It's basically extending, meaning it's inheriting all the behaviors, right, all the capabilities that the CRUD repository has, and it's been configured to CRUD courses. Let's see. I think there's a question on the chat. In the CRUD repository, a built-in interface is the course repository a built-in interface in the import package, or do we need to create it ourselves? No, it's already for you. It's provided by the Spring template, by the Spring framework, right? So you don't need to do this yourself. It's already built for you. You're just extending it. You're inheriting its capabilities, right? So you do not have to. You can override its capabilities. Maybe you don't like the way it does certain things. You can override it, and we will certainly override a couple of things, right? But out of the box, it's got everything we need, right? Yeah. So and you can configure it to store anything you want, any table you want, as long as you can map the data types and the fields and whatnot. Okay. All right. So there you go. So we got the repository, and the repository basically provides generic versions, generic functions, generic versions of what you would implement in your DAOs, right? Instead of find all sections or find all courses, it implements a generic version called find all. See that? Instead of implementing specific, find section by ID, or find course by ID, it implements a generic version called find by ID. See that? So the challenge is that, well, how do we use these generic versions, right, to implement our specific versions, right? How do we do the mapping of those two, right? Very easily, right? Well, let's see. For the course DAO in the course DAO, let's implement it, right? But we're going to implement it in terms of our repository, which already implements a lot of what we need to do, right? So we're not going to implement it. We're just going to reuse what these repositories do. Okay. Where's the chat? Okay, there's the chat. Yeah, so let's start off by creating a class called course DAO. Right. So in our DAO, we'll implement our course DAO. There it is. Okay. And we're going to use the repository that we just created, right? So it's the course repository. Okay, what do we call it here? Yeah, course repository, perfect. And we'll implement some of these functions. Let's copy these two functions. So let's go over it together. Okay, so this is the course data type we created earlier. There is, we're going to import that. And that's it. Okay, so let's take a look at the implementation. Very easy. So to implement our find all courses, we're going to write it in terms of our generic find all. See that? So find all returns an iterable, right? Meaning something that can be iterated over. So basically an array, okay, or a list. And that it's an iterable of courses. So it contains an array of courses, which is perfect. That's exactly what we want. Okay. And find course by ID is written in terms of find by ID. So a generic finder method here, right? That takes as argument your primary key, which it knows it's an integer because we told it, right? When we created the repository, we told it that the primary key is indeed an integer. Okay. Why is the chat going away all the time? Oh, I know, because this is there we go. Okay, that should be better. Yeah. So we're writing our specific finder method in terms of this generic finder method. The only quirk here is that we need to use this get, right? Because again, the object that's in there is it's generic. It needs to know that it needs to cast it to the correct data type course, because it's just a generic object. You know, it needs to be able to convert it into the correct data type, and that's .get will do that for us, right? Again, that's a quirk of using this ORM. You know, each ORM that you use will have its own little quirks that you need to know about, right? All right, so let's implement a couple more. So here we can create an entire course. Okay, there's a question in the chat. Why do we get as opposed to casting? Yeah. So what happens under the hood here is that this finder method, method. Let me just comment that out for a second, and let me show you. This finder method actually returns a what is it? Observable? I forget. Let me see. It returns. Okay, it returns an optional. It returns an optional. So you would have to put it in an optional. Okay, an optional of course, which allows you to check to see if, right, if the object, if the row that came back actually contains something, right? So you can ask yourself, you know, if the optional is present. Okay, this allows you to treat records that come back as null, meaning there was no record, there was no course with the ID, course ID, right? And the way you would deal with that edge case, right, is that you can ask it. There's an API for checking, hey, was there an object that came back? If it is, right, if it is, you can then unwrap the actual object. The object is inside of the optional. So you can say optional.get. Get allows you to retrieve the actual course. See that? The get right there? And you can just return the get. See that? Otherwise, you return null. Okay. So this is very too much information, I think, TMI. So what I did is that I'm going to be lazy about this. I'm just not going to do that. I'm just going to assume I'm going to assume that that course ID that you gave me is valid. I'm not going to do any validation whatsoever, right? And I'm just going to blindly return the object that's in there, right? Obviously, this would throw an exception if that ID doesn't exist, right? Because I'm not validating, I'm not treating it, right? But again, to keep it simple, right? To keep it at a minimum of what you need to do and what you need to know, I just wrote it, as simply that, right? I didn't want to get into this conversation, but yeah, this is enough, right? If the idea you give me is valid, everything's good. Okay. So you're welcome to explore some additional features and whatnot, but this is the absolute minimum that you would need to get this going, right? Anyway, we're going to override this, and we're going to make it look even prettier. So I don't really need either one of these. I'm going to, we'll see a little later how we can override the underlying behavior so that this would look even better, even prettier. Okay. All right. So let's keep going. So let's look at create. So remember, we're implementing the CRUD operations, right? Create, read, update, and delete. So find, these two finders implement the R, the read operations. The create course implements the C, in the CRUD, right? Create a course. And to create a course, we're using the generic function, right? Save. Now, save is a very smart function, right? It sees that if you're passing in a brand new object instance, like we are here, right? This dot save translates into an insert, right? It inserts a brand new record in the database. If instead you pass it a course, right, that comes from an object that already exists in the database, right? Save is smart enough to say, oh wait, this is a object reference is for an object that already exists in the database. Then this is an update, not an insert. Right? So save is pretty smart, right? It can either do an insert or an update, depending on whether the course is a brand new record or an existing one. Okay, so so just save, it inserts that, right? There's delete. So delete is also using the delete by ID generic function in the repository to remove a course from the database. Perfect, excellent. That's exactly what we want. And finally, we have the update. So the update, let's take a look at this. So update is a little bit more involved, but not that bad. Let's see. So update, we need to know the ID of whatever it is that you're updating, and we need a new version of whatever it is that you're updating, right? A new version that has new data, right? So the way it works is the ORM. The way it works is that you first need to go fetch the record that you want to update, right? So you go out to the database, right, and copy that data from the database. You copy it over, right, to your variable, right? So this is what we're doing, right? We're using the generic find by ID and get and whatnot, right? We're retrieving it. Once we have it here, then you can update whatever fields you want to update. Like for instance, we change the title, blah, 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 right? Or we can change the number of seats, the date that it starts, the semester, blah, 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 whatever fields you want to update. And then you use the dot save again. See this dot save? This is the same dot save that we use here to insert the record. But because here we are passing an instance that already exists in the database, right? It's smart enough to know that what you mean here is an update, not an insert. So this will issue an insert command as opposed to as an, I'm sorry, will issue an update command as opposed to as an insert. That makes sense? All right, basically we're done, right? We have our DAO. Let's now try and play with it, right? Let's play with it, right? So how do we use this, right? So one of the more interesting ways of using this is to make this available, right, on the internet, right? So that if anybody wants to access our data, right, if they know the URL or the server where this lives, that I can integrate with it by hitting that URL. And this became extremely popular, right, at the turn of the century, right? Lots and lots of different companies, Microsoft and Oracle and all these huge companies. They were in a huge race to implement technology like this, right? To allow multiple companies and enterprises share their data easier and just smooth out the the interfaces between disparate systems, right? That some folks might be talking Oracle, other MySQL, blah blah blah, all different ones, and the data format was binary, and so this allowed them to very easily integrate between them. So the way we do the integration is very simple. Let me just remove some. Okay. The way we integrate is very simple. We do the following, right? We first put this whole class on the internet. Boom! It's already on the internet, right? We can start hitting it with HTTP, and we can execute things in here, right? First of all, let's execute this really simple one. Find all courses, right? We need to tell it, what URL do we want to use to invoke this information, this function. We want to run it. We want to run it when an incoming URL comes in, and it looks as follows, right? And here you can put whatever you want. You can just map it to whatever you want, right? Now there are some standards on what these URLs should look like, right? For instance, there's the RESTful standard. Well, not a standard, but more like a naming convention, like a coding convention. But for now, we're just gonna keep it simple. We're just gonna put something simple. We're gonna maybe find courses or something, right? Find courses. Let's do that, right? If the URL looks like that, this function will execute. It will issue a select star from courses. It will iterate over all those records. It will create an iterable courses, and it'll come back with an array of those objects. Okay. All right, let's try it out. Okay, so one more thing, we need to auto wire this, meaning we're asking the infrastructure, the Java server infrastructure, to instantiate these repositories, right, and then provide me with a link here, right? It's an example of dependency injection, right? Another very mature design pattern that has become very popular, in component-based programming, right? All right, so let's try it out. I'm going to start the server, and so the server is going to, it's going to find this get mapping. It's going to register this URL, and it's going to listen, to see if people are hitting this URL so that it can execute this function. All right, so let's try it out. Let's see. Well, let's go to localhost 8080, and this find courses. There it is. There we go. Right. So we got all those courses, even including the new courses that we added just a few minutes ago. Right. Those are the 3 courses or 4 courses that we added a little bit. Notice also you can see the actual select statement that was issued by the server, right? That went out to MySQL, logging in and blah blah blah, all that, and issuing that command. So you can see the SQL that is being generated. All right. So how about finding a specific course by its ID? So let's copy the URL And let's just modify it a little bit, right? So we will say that, if you want a specific course, you need to provide me the ID of the course that you want. So we'll do that by creating here a variable on the path, right? And we'll call it course ID. Okay. And so notice the curly bracket, meaning that this is a not a literal string, right? These are literal strings, so they have to be exactly /find/courses, right? Slash, and then this last one is like a placeholder. It could be anything, and it could be first characters, it could be anything. Hopefully, it's an integer. Hopefully, it's an integer that we can map to this course ID here, right? And then use it to retrieve this find by ID. Okay, so let's do that. Well, so I'm going to parse from the path. I'm going to parse this variable right here. Okay, and we do that with the annotation path variable. See that? And here we can say, well, which variable do you want to parse? Because you could have many. You can have a whole bunch of variables, right, as part of the path, right? So you need to tell me which one. Well, it's this one. This one I want to parse. I parse it. It'll also convert it into the right data type, right? If this were an integer or a date or a string or whatnot, right? It will cast it to the correct data type. In this case, an integer, right? Obviously, if it's not an integer and you provide me with a string, right, this will throw an exception, right? And what is it going to do with that ID? It's going to go out to the database, do a select star where ID is a select star from courses where ID is equal to CID, right? And then that one record will be returned, right? So let's try it out. I'm going to restart the server. So if you head over to the list of all the courses, right? We have all these courses. So say we want to retrieve one of our later courses here, maybe say 3200. So that's ID number 7. So the URL, I believe it's find/courses/ the ID of the course that you want. So let's choose 7. And indeed, there we go, right? We got course ID 7, which is CS3200. Yes, which is perfect. That's exactly what we want. Well, let's play around with some of the other ones. Okay, let's see. I think there's a question on the chat. To parse another variable, do you need a new path variable or just add another string as argument? Yeah, you can have several of these, and we'll do it when we get to create course. I'll show you how to have multiple path variables, right? We'll do that in a minute. Okay. All right, so let's keep going. Let's delete a course over here. Delete a course. And so to delete a course, and you need to tell me the ID of the course you want to remove, right? And so let's map it to say, let's see, delete course. We're going to say delete course. I'll keep it as courses just so that it's easier for me to remember. And then the ID of the course you want to remove, right? And so we're going to just parse it here. Right? We're going to say path variable and the course ID. This one right here. And I'm going to map it to that integer. Let's try it out. Let's restart. Let's it's still booting up. Still booting. Come on. There we go. Okay, so let's remove. Let's see. I don't know. Let's remove 5610. So we'll remove number 9. So this would be delete courses and then 9. Let's go back. Let's refresh and see if 9 is no longer there. So if we have just 8 and 10. Okay, let's refresh. There we go. We have 8 and we have 10. Number 9 is gone. All right. Okay, so let's do one more. How about create course? I guess we only have a title, don't we? All right, that's fine. We can only create with a title. All right, so let's do a create. So create create, right, courses, and then we're going to provide here maybe the title of the course, So notice that the function is actually expecting an object, okay? So this technique that we're using, you can't pass an object. You can pass individual primitive types, right? A string, an integer, a date, right? But you can't pass an entire object. There are other techniques that we're not going to cover that are a little advanced where you can pass an entire object, but I'm going to leave that maybe for next week when we play around with something a little more powerful, okay? There's a question in the chat. Can you use a markup language to edit the appearance of the site? Can you use a markup language to edit the appearance of the site? I'm not sure what you mean, the site. The appearance of the site. Which site? The one you've been going to. Oh, you mean this here? Okay, this is not a site. Okay, this is not a site. This is a plugin that pretty prints what's coming back from the server. Actually, the actual what's coming back from the server is this. It's just plain text. Right. So the server is returning just plain old text. Yeah, no. It's fine. It's what I'm trying to say is that this is not a site. This is a server that is listening at a particular port at a particular URL, and we're asking it to return raw data, right? That is formatted as a string, right? It's a special type of string. It's a string formatted in JSON or JavaScript object notation. It's a very common format that folks are using to exchange data on the internet, and so that's why I'm presenting it. It's it's very popular out there in industry. So it's not a site. A user interface would consume this data. A user interface application would consume this data and then render it in any which way you want. And that's what the topic of next week is going to be. So next week we're going to hit these endpoints with data, asking for data, and then we'll render it in a whole bunch of different ways. Okay, so yeah, that's the topic of next week, right? So yeah, so right now the only thing that we can pass along in the path, right, are just strings. Right? And I have this little plugin that, oh yeah, see, there's the raw. See the raw? This is what's raw coming back from the server, just raw string. And I just have a little plugin that parses it and makes it pretty like this. Anyway, so yeah, so the create, we have a title. We can't pass objects, right? So what I'm going to do is I'm just going to copy this. I'm going to comment it out. And instead making it a little bit simpler so that I can actually pass something to you. So this is the title here, okay? And what we're going to do is that we're going to parse that title for the course from the variable. So path variable, and it's called title, mapped to title. Very good. And we're going to instantiate a course object, right? Because the save is expecting an actual object, okay? So we'll create a course here, new course, and we're going to populate it. We're going to populate the title, right, with the title that we just read from here, okay? Oh no, not get title, set title. Sorry, set title. Right? Is there anything else that we can set? Course.set. Yeah, course ID. We don't want to change the ID. We already, yeah, we don't want to change the ID. All right, so let's try it out. Let's create a new course. Let's see. Let's restart the server. And let's refresh. Let's see all the courses. There's all our courses. Let's create a brand new course. So we'll say create courses, and this will be CS ABCD. Enter. Okay, there it is. It created with a new ID, course ID. There it is. Right. If we go back, right, if we refresh, notice that we got 12, number 12 here. Also, if you go to the database and you refresh, you'll notice that our new course is there. Perfect, excellent. One more thing, let's do the update, right? The update, here's our update. Again, this update is expecting an entire object. We can't do that. So let's keep it simple and let's just provide a string for a title that we want to change from an old title to a new title. So let's do that. So I'm just going to copy this and just comment it out. And so instead of the new course, we're going to pass in a new title. How's that? Change the title. Okay. And here's the example that one of the students was asking for. Can we pass more than one variable? Can we pass something more than just one thing? Yeah, yes, you can, right? So basically, you can pass in any number of things, right? In the path, we'll say update. So the first variable here will pass in, say, the ID of the course, and then add another one at the end where we can pass in the title. See that? And then we can parse these individually. We can parse for this, we can use a path variable to read the course ID, and for this, we're going to read it from the title. Let's do that. We'll do path variable, and there's the course ID. There it is. And we're going to map the title right in here. So now we've read two things from the path mapped into two different variables locally in the parameters, right? Which we can then use to the ID. We can use it to retrieve the course. Yeah, we use that to retrieve the course, and then we're going to set the title to be the new title. You see that? Okay, let's try it out. Let's run it. Let's go back and see. Let's see if the server's booting up still. There we go. So let's change the course. Let's change the course here, a title that we changed here, that we created earlier, ABCD. So we're going to say update courses number 12, and the new title will be CS, I don't know. It was ABCD. We'll do EFG. Whatever. Let's do that. Let's refresh. Okay, so this used to be the old title. If we refresh, the new title has been changed. That makes sense? All right, excellent. So there you have it, right? We can create that. We can absolutely create a crud operations, right? That is accessible to the internet. Anybody who wants to interact or interface or integrate with us, right? They can absolutely use this API. Let's see. There's a question on the chat. It says, would it be possible to use overloading so that there is one method call update course that takes courses, doesn't have a mapping? Yeah, absolutely. Yes, very good. I could certainly have done that, right? So we could, you could have two, right? One uses the one here. Yeah, this overloading. So one of them uses this, right? And the other one uses the other one, right? So this would be, new core. Oops. What did I do? New course, and this is new course dot get title. So this is the original. That's the original. That's the original code, right? Obviously, the mapping would have to be different. You cannot have two different methods mapped to the same URL, right? That's a no-no, right? The URLs need to be different, right? Next week, right? Depending on how we do, right? We'll see that really what we want to be able to post. Really, what we want to do here is use a post, not a get, right? And to just post like that, and read it. Read the read the ID from here. Yes, read the ID from here. and but the data is being passed as a body in the body, requests body. But that's too advanced right now. I didn't want to bring it up. And this would be a path variable. And this is ID. Okay, so yeah, so you can post and send the data embedded inside of the request, and then you can parse it out as an object, right? And pass the ID as part of the path, but the data as part of the body. But again, that's a little bit too advanced. I don't want to discuss it right now. All right, excellent. So we've demoed that we can absolutely create a data model in the object world, and we can map it to a relational world, right? And then we can expose that data model out to the internet so that folks can integrate with us, right? Maybe suppliers can integrate with us, right? Other companies, and then we can smooth out the communication between our partnership. All right, let's move on to better things. All right, so testing, we did that, right? Endpoints, we created the find all, we did all this, right? All right, so let's do a little something a little more interesting. So we started off with the table courses, right? We started off with the table courses, and we created a Java object, right? A Java class that was mapped to that table, right? And we said that that table was, some legacy table that's been around for years. We can't touch it, right? We cannot change its schema, right? We can only integrate with it, right, by creating a correspondent class like we did here, right? Okay. What about if instead there is no table, right? And actually we want to go the other way around, right? What we did is that we mapped a table, we mapped it to a class. Well, it turns out that we can go the other way around. We can start off with a class, right, and have it be mapped to a table, right? That's very, very exciting, right? That you can go both ways, right? You can either, right, take a schema that already exists and map it to an object schema, or start with an object schema, right, and then map it to a relational schema, right? Let's do that. All right, so to do that, let's create a class of sections, and I have a table here. I'm going to blow away the table. I'm going to blow away the sections table. Say drop now, and let's refresh. Right, notice that there is no sections table. It's gone, right? There's no sections table. I'm going to start off by creating a class called table, a class called section. Right, so let's do that. Let's do a model, say new Java class, and this is a section class. And in here, you can have things such as, let's see, section name. There we go. We have an ID, which is presumably going to be a primary key, and we have the name of the section, right? We can have other things, right? We can have maybe, how many seats? How many seats does that section have? Okay, it might have maybe a semester. You can have a whole bunch of things, right? Whatever. Okay. Yeah. So notice that there is no table, right? I just want to point out, right, there's no table in the relational database, right? But I can start off with a object schema, right? A structure of the data at the object level, and then I can ask my ORM to map this class to an equivalent relational model, right? Let's do that. So we start off with saying we have an entity, right? We want to map this to a table. By default, it would create the section table, right? That's not exactly what we want. Actually, let me show you, right? If I just do this, I also need at least an ID. This is absolutely the minimum I need. Well, I need the setters and getters. Let's create the setters and getters. Code generate the setters and getters. So, okay. there you have it. So let's see. Let's if you restart this, let's restart the server. What the infrastructure is going to do is going to generate the SQL create statement that will generate this table. There it is. Look at that. See that? Let's copy that. Copy that. So there we go. So it created the SQL that creates a table. So first check to see if the table was there, right? Since it didn't find the table, it says, ooh, I can create the table. So it creates the table. Notice that it uses the correct naming convention, right? It grabs the section ID and calls it section ID. There it is. See that? Notice that it did not use an auto increment. That's interesting. Seats, section name, semester, and it declares the section ID as its primary key. See that? Right? If you go to the relational database and you refresh, notice that we have a section table. See that? So it took the name of the class literally as the name of the table, but lowercase. Okay? So it's not pluralizing it. It's not doing any of that, right? It's just taking verbatim the name of the class, right? Now we can override that and say, well, we don't really want that name. I really want the name of the table. I don't want to use the default. I can override that and say that the name of the table that I want you to use instead is sections. Okay, and the name of this field, the name of the primary key, I can override it and say that the name is actually, I want it to be just ID. Okay, and right, the name of this field, I want it to be name. Right, I can override those defaults. Okay, right. Okay, so let's see what else. What else do we want to do? Well, one of the things that we might want to do as well is that this primary key, I don't want to be responsible for the values of it. So I don't want to have to create those unique identifiers. So instead, I can annotate it to be a generated value using the strategy identity, which is going to be the same thing as an auto increment. Okay. All right, let's restart the server now. So if we restart the server, again, it's going to look for a table called sections. It's not going to find it, right? And it creates, there it is. See that table? It creates a brand new table, called sections, right? Pluralized. See, table sections, right? Also notice that it added the auto increment. Also notice that the primary key now is called ID, not section underscore ID. Also the name, right, instead of section name is name instead of section name. See that? So we could override that, right? Okay, so how about if we add a new field? Okay, let's say we want to say, I don't know, year, right? The year that this section was offered, say. Okay, if we code generate again the setters and getters, right? We have the setters and getters for the year. Now notice if I restart this, look what it's going to do. Right, so it checks to see and it realizes the table is there. The table is already there. So notice what it does. It issues an alter command. See that? Our ORM, right, knows exactly how to interact with the database. It's the same commands we would have typed at the console, would have, and run it at the console using Workbench. It's generating all this, right, from us working at the object world, right? It is mapping all the changes that we're doing at the object model, and it's bridging, right? It's mapping these things to the relational world, right? That's why it's called ORM. This idea of mapping objects to a relational world, right? And again, this is done in Java, but if you're using Python or using .NET or using any other of these ORM solutions, right, they would, most likely they would behave, the same way, right? Obviously, each one will have its own little quirks, right? Its own little things that you need to learn and gotchas and whatnot. But for the most part, right, they are very, very similar to one another. Everybody good? All right, let's do something a little more interesting. Let's keep going. Yeah, so he created it. All right, let's talk about one-to-many. Right, so one-to-many. Right, so up to this point, we have been talking about individual classes, right? The course class, the course table, and then the section class has its section table. But more interesting is when you start talking about multiple tables, right, that are related to one another, right? So for instance, it'd be very common that a course might be related to many sections. One course has many sections, right? And we have been referring to that as a one-to-many, one-to-many. And there are all sorts of types of relationships that we considered, all the way, up to this point when we've been talking about relational databases, right? The one-to-many relationship, many-to-many, associations, aggregations, and composition, right? Cascade deletes, all those kinds of things. We also want to be able to bring that and control that from the object world, right? So let's start with one-to-many first. Okay. So how do you do that? How do you tell the object world that we are participating in one-to-many relationship, right? So the way we do that is as follows. Now the way we implement one-to-many in the object world, right? When you think about it, we would implement it as follows, right? If one course has many sections, the way to think about it from the object-oriented class world, you would do the following, right? If this were Java or Python or some object-oriented programming language, the way you would implement one-to-many is straightforward, right? What you would do is the following. You would say private list of section, and then you have sections. Boom, that's it. That's all you would do. As far as object-oriented programming is concerned, that's it. That's how you implement one-to-many. The parent course, right, has either an array, right, or some collection or set or map or list of its children, right? It is the parent who has references to its children. Okay, right? Very seldom, for instance, very, very seldom would you have the children, right? Very seldom would you have your children refer to its parent, right? In the section, being the children, would you very, very seldom would you have the children also refer to its parent. But because this is a relational, we're going to map this object-oriented world. We want to map it to a relational world. It's backwards the way we implement one-to-many in a relational world, right? The way we implement one-to-many in a relational world, it is the children who have foreign keys to its parent. Okay, right? You would have sections have foreign key to its parent, right? So in a relational world, the course would be completely unaware of its children's section. It would be the sections who have foreign keys to its parent. See that? That's how you implement one-to-many in a relational world. But the way you implement it in an object world, it's backwards. It is the courses who have arrays of sections. It is the parent who has collections of its children, right? And very seldom would you have the children refer back to the parent, right? So there's a gap here on how you think about one-to-many in the object world and how you think about one-to-many in the relational world. So we need to bridge this gap, or this conceptual gap. And the way we bridge it is by basically doing it, creating both, representing both possibilities, right? We're going to add a reference in the child, in the section, on the many side, right? On this side of the many side in the section, we're going to, to represent this foreign key. we're going to have a reference to the parent, and to implement it in the object world way, we're going to have a collection of its children, right? So we're trying to please both sides of the world, right? We're trying to please the object world, which wants an array or a list of its children, and we're trying to please the relational world that wants a reference from the child back to its parent. See that? So eventually this is going to be converted into just a primary key, right? I mean a foreign key, sorry, right? So how do we convert this into a foreign key? Well, again, using our ORM, right? What we're going to do is, right, we're going to annotate the course. We're going to say we are on the many side. We are on the many side of a one-to-many relationship, right? Basically this, right? So let me copy this here, and let's bring it here. Right, so section, right? The section class. This section class is on the many side, right, of a one-to-many relationship. So this annotation says that I am on the many side of a one-to-many relationship, right? And so what the ORM is going to do is when it parses this, is going to convert this into a foreign key in the relational in the relational model. Okay. Now the course has the array, right? Has the array, right? So basically, right, we need to annotate and say that this course is on the one side of a one-to-many relationship, right? And we annotate it using the one-to-many annotation. See that? Right? Well, let's do that. Let's copy this one-to-many, and let's annotate it here. There we go. And then on the one side, right? On the one side, we're going to copy this one-to-many right here. Okay, so we are now on the one side of a one-to-many relationship. Okay. Now notice it says mapped by course. Mapped by course. What's all that about? Notice that this course is the name of the field that we're using here. See that? Right. This is the name of the field. It's saying that this is basically saying this array, right, is tied to this foreign key here. Right. Now the reason for this is that there can actually be several one-to-many relationships, right, between two classes. For instance, imagine a faculty and a course, right? A faculty could have two different one-to-many with a course. For instance, a faculty could be teaching many courses, right? So that's a one-to-many relationship between faculty and courses. Yes, faculty teaches many courses, so one-to-many. But the faculty can have a different one-to-many relationship between a faculty and a course. Maybe he's the author of many of these courses, right? So that's another one-to-many relationship. And we want to be able to distinguish them, right? One is teaches the courses. I could teach courses that I don't author, right? That some other faculty authored them. Or I could author different courses that I don't teach, right? So they're two distinct one-to-many relationships, right? So that's why we want to be able to tie, right? Make sure that, right, we distinguish the possible one-to-many. Okay, there's a question on the chat. Let's see. So you have a label. So wait a minute. So you have to label the variables and classes. You mean this? You mean? Well, yes, this actually does refer to the name of that field. Yes, in this particular case, yes, you do. Again, to be able to distinguish if you have more than just one-to-many, you can have many one-to-manys, right? So you need to be able to distinguish which one is which, right? We don't have anything like that, as complex as that, so we don't really need to, right? But by definition, you need to specify the variable that refers. And that's actually going to be used to calculate the name of the foreign key, right? All right, so let me just show you. All right, there's another question in the chat. When you when you made the class, did you label the class too when you did the class? The section you mean? Well, we labeled the as entity, and we also labeled it as the table that was going to be implemented. Yes, yeah, of what is going to be generated. Right. So let me blow away the section table because I just want to show you the entire create statement that it builds. Right. Let me actually no. It's interesting. Just by adding those two things, by just adding this this one to many. I mean this many to one, and adding this one to many. Now let me show you what it generated. Let's restart the server. Look what happens. So what it's going to do, it's going to add a field. There it is. See that? Let me copy this so we can see it better. So it's issuing the following commands on the section table. So on the section table, it's adding the following. First of all, it's adding a brand new field to the sections called course ID. See that? This course ID, that's going to be the foreign key that references the course. Notice that it first adds the course ID field and then adds a constraint saying that course ID is a foreign key that's referencing the course's primary key ID. See that? I mean, that's cool, right? That it's we're here building our data model in the class using objects and classes, and it's issuing all these commands, right? All these SQL commands, which that is manipulating the SQL, right? The relational model. And so notice that if we refresh here, right, and look at the schema, notice that it has where is the we refresh column. Oh, interesting. Wait, where's my course ID? Why isn't that showing my course ID? Oh, not section. I'm sorry, sections. There we go. There's our course ID. Perfect. Yeah, year and whatnot. Okay. Yeah, see, it adds all those fields, right? And so it's generating all this code, right? So this is kind of like the dream of software engineers, right? The ultimate programmer is the one who can write programs that can write programs, right? So the ultimate automation is to write an automator, right? So instead of me having to write things, eventually I'll have some Oracle that can write things for me, and so that's kind of where we're going to, right? Let's see the question on the chat. So even though you made the field in the section table object of type course, SQL Java knew to make the foreign key. Yep, exactly. Yep, it figures out that it understands that in the object world, you want references, right? You want object references, right? And it would make no sense to have foreign key here, right? That's a explicitly relational world concept, right? It makes no sense to have foreign keys here. So instead, right, they're mapped to object instances and references and pointers, right? Which is what makes sense in the object world. Okay, excellent, perfect. So let's now insert some data, right? Let's insert some data. Let's add a couple of sections, right? And associate them to several courses, right? So let's go here, right? And let's do a couple of these inserts. Now these inserts need to be in their individual line, otherwise it barfs. Right? And we'll execute them one at a time. So we'll create one section, we'll call it section 1, 2, 3, and its parent course ID. Oh, wait a minute. I need to say into sections. we want the ID, and we want the name, and the course ID. Course ID. Yeah, I deviated a little bit from the slides, so I need to add this. So let me add here. Okay, let's try running this first one. Okay, that's okay. About this one, good. That one, that one. Okay, let's retrieve all the sections. There we are. We got sections with the course name, the sections, and the courses they belong to. So 2 sections for course 1, 3 sections for course 2, and 1 section for course 3. Perfect. Excellent. So let's now revisit, right? Actually, did we update? I forget. Do we have all the setters and getters? Let me make sure we have all the setters and getters. Generate all the setters and getters. Let's see if we missed something. Oh yeah, we need one of the course. We'll say, yeah, we want the course. And for the course, let's see if we have all the setters and getters for the course here. We probably don't have for the new sections, right? So course generate, and we'll say setters and getters for the sections. There we go. Okay, excellent. Let's restart the server, and let me show you something. So if we go back to trying to retrieve all the courses, look what happens. So this was the original implementation of retrieving the courses, right? Right. If we refresh, notice what happens. It gets into an infinite loop, right? I'm going to stop the server because it's going to crash, right? So what it did, right, is that it says, okay, well, I'm going to go fetch the course. Now, before it was just one table. It was just a course table, and then you had the sections table. Yes, but now somehow they are related to one another, right? So there's kind of like a join here, right? Where you want to be able to retrieve some information from the course and some information from the section. For instance, for the first course, we know that there are 2 sections associated with it, right? So we retrieve the course ID, the title, blah, blah, blah. And here are the 2 sections. So we start filling out the information for the section. The section ID 1, section 1, 2, 3, blah, blah, blah. But look at that. When it gets to the course, it kind of goes back to where we were here. See that? And it tries to recreate it again. And here's the sections again. So see that? It gets into this infinite loop of going from the courses to the sections, from the sections back to the courses, from the course to the section. So this is trying to convert this back and forth, right? So we need to break that. Okay. And one way to break it, obviously one easy way to break it is to not provide the setters for this, right? Right? Yeah, it's an infinite recursion. So we could just remove this, the get, right? But that would defeat the purpose of the object-oriented implementation, right? Just because we don't want it to go into an infinite loop when we try to convert this into its string doesn't mean that we don't want to have access to the course, right? So what I'm going to do here is I'm going to say, yes, you can access the course programmatically, blah, 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 right? But for the purposes of converting this into a string for JSON representation, for integration purposes, for some client that needs to access this data, right? For integration purposes, stop, right? Don't try to convert this, right? Don't try to convert this. So stop here and just ignore this field, right? Ignore this field. Otherwise, you're going to get into this infinite loop. Okay, so let's restart the server. And so what it'll do is that it will retrieve the integer, the year, the semester, the seats, but it will not try to get the course because that will loop back into its parent. Right? So if we refresh, this now we have what we expected, right? We have the information for the course, the 2 sections, right, that are its children, as an array, perfect. Okay. For course number 2, we have 3 sections for that course. And finally, the lonely section for course number 3. And the other ones don't have any sections as represented here as an empty array. See that? Excellent. Excellent. We have we have implemented, right? We've come a long way, right? We've been able to implement one-to-many, right? Been able to map from a table, right? We went to implement an object world from the relational world. We were able to implement an equivalent object representation, and vice versa. Starting from an object representation, we were able to generate an equivalent relational world, right? And then expose the data model to anyone who wants to integrate with us, right? Wants to retrieve data, right? Or add data or update data, right? If we would have to advertise, right, to whoever wants to integrate with us, we would advertise these URLs, and folks could create all sorts of applications, right? Mobile applications, desktop applications, web applications, right? And the interface would be based on these URLs, right? And then obviously being able to parse this data into whatever, however you want to consume it, right? And whatever UI that you want to represent it. Okay. There's a question in the chat. It says, do you have to worry about inconsistency in the one-to-many relationship? For example, do we need to worry that the section will point to a course, but the course will not contain that section in its list of sections? That a section will point to a course, but the course will not contain. No. If the this is strictly being resolved by the section pointing to the course, right? So that from a relational standpoint, it is the sections who have foreign key to the course, right? Now, what the ORM does for you is that it allows you to consume it the way the object world would consume it, right? You can go either starting from the course and ask for the section and then iterate over the array of sections, right? So it will populate that array of sections and allow you to treat it as if this were objects containing other objects, which is the backwards way of thinking about it from a relational world, that it is the children who have references to it is the section who has reference to the course, right? So the relational world, so once these two are mapped, right, the object world allows you to consume it both ways, either the parent going down to the children, right, through the iteration of the array, or from the child navigating back to the parent, through the reference to his parent, right? Which is basically what you have in the relational world, right? Normally in Java, you would have the relation would be one direction. It would be you could only navigate from the parent down to the children through the array. Normally, you would not add the reference from the section back to the course, right? Normally, you would not do that. Normally, it would be just one directional. But because in the relational world, it's bidirectional, right? That you can navigate from the courses table down to the sections table, or from the sections table back to the courses table by just joining, right? By just saying that the primary key is equal to the foreign key, right? With that join allows you to navigate, between the tables any which way you want, right? Not so in Java, right? So we went out of our way to provide that bidirectionality also in Java, which it would not be normal, right? So we went and actually provided a reference from the section back to the course because we want to provide the same capabilities that you can in a relational world, okay? Again, some of the compromises that you need to make because we're trying to bridge these two worlds that are fairly different from one another, right? Let's see, question in the chat. Can I see the code that fixed the recursion? Yes, sure. Yeah, so what we did is we added this JSON ignore. It's also part of the slides. In the slides, they cover it, right? So it says that you can have a circular reference, right, that you can then fix by adding the JSON ignore. So it's in the slides. I'm also going to push this code and make it available to you, right? If you want to take a look at that and play around with it on your own at your own pace, so that you can use it perhaps for a potential project. Okay. All right. Let's see. There's a question in the chat. It says, "I have a question about the quiz. Can you clarify what that is going to cover. Yes, so the quiz is going to cover the stored procedures and functions. No triggers.
Thank you.
Stored procedures and functions. All right.
Professor, I had a question. It's not strictly related to today's lecture, but what's the difference between JDBC and ORM?
Yeah, so JDBC is the underlying infrastructure, right, that knows how to talk to a relational database, right? It's a very low level API that allows you to be very specific on getting a connection, right, logging in, sending a specific SQL, and then iterating over the result set, right? So ORMs is built on top of JDBC, right? So all those SQL statements that we see are being sent to the database, it's going through JDBC, right? So the ORM is a very high level API that allows you to think about the database as an object, right? As a whole bunch of objects that are related to one another, but underneath, right, all that is translated to JDBC actually talking to the database.
Okay, so you need a JDBC to use the ORM, right?
Yeah, all communication to a database always goes through JDBC, but we're not coding in JDBC, right?
Right. Yeah.
Just like all code gets compiled to assembly, right? And when it gets executed by CPU, you don't code in assembly, you code in Python. Yeah. That gets compiled down to something that it's interpreted by something more fundamental, right? So ORMs allow you to code very, very high level, and it gets converted into low level JDBC calls. But you don't need the JDBC.
Okay, great. Thank you for the clarification.
Sure.
Excuse me, Professor. Sorry to take up more time here.
But, oh no, not at all. Go ahead.
For the quiz this weekend, it's due on Sunday night at midnight, right?
I believe so. Yes.
Okay, and it's I saw it's 28 points. So, should we be expecting like a longer quiz than normal, or
no,
more intensive?
Or? 2 questions, but it has a lot of fill in the blanks.
Okay. All right. Great.
Each fill in the blanks is like 2 points or something.
Okay. Awesome. Yeah. Sounds good. Thank you. Have a good weekend.
All right. All right. Thank you, everyone. Have a great weekend.
Thank you. Have a nice weekend.
Bye-bye. You too. Cheers.